Okay. Am I audible? No? Hello. Am I
Yes,
audible?
yes, sir.
Yes, sir.
Okay, fine. So I think up to this we discussed about the nomenclature of heterocycle, and also we discussed about synthesis and reactions of pyrazole and imidazole. So from now today we will discuss about the synthesis and reactions of oxazole. So oxazole means in a five-membered ring, if the oxygen and nitrogen are at 1 and 3 position, then it is said to be oxazole. So let us uh, make it in a presentation mode. Okay. So let's see, is anybody is waiting? Yes, let's give an entry. Right. So let's make it presentation mode. Okay. And let's take a pointer. Okay. Visible now? Screen is visible now?
Yes, sir.
Fine. Okay. So oxazole. So oxazole means in a five-membered ring, oxygen and nitrogen, if it is at 1 and 3 position, then it is said to be oxazole. Is somebody is waiting? Let's give an entry. Yes. Right. Let's make it presentation mode. And let's take a cursor, laser pointer. Right. Okay. Oxazole. So oxazole means in a five-membered ring, if the oxygen and nitrogen are at 1 and 3 position, it is said to be oxazole. So, but here I am making R1 and R2. R1 and R2 may be a substituent. So where and all it's present, this substituent, it's present at second position as well as fourth position. If you want to give a numbering to the oxazole, the preference should be given to the oxygen. That means this is 1, 2, 3, 4, 5. So in that way you need to number. Then, but how one can synthesize a 1 comma means oxazole? Of course, it's a substituted one. Suppose R1 and R2 is equal to hydrogen, then it is a oxazole itself. This oxazole can be synthesized or prepared or manufactured or produced, okay, in a laboratory or in the plant. Okay, so it can be started with a compound. So what is the name of this compound? This is a carbonyl compound, and adjacent to this carbonyl compound, this carbon is called alpha carbon, and X is equal to halogen. So halogen, where it is attached? It is attached to the alpha position. So that means alpha halo ketone. Alpha halo ketones when it is treated with amide. So CONH2 containing functional groups are called amides. So that means alpha halo ketones on reaction with amide gives a oxazole. Otherwise, what we can say that here what you can observe, there is a removal of HX, means hydrohalic acid. HX means hydrohalic acid. That means hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen fluoride. All these are compounds are called HX, and it's a simple molecule. So that means it's a condensation reaction. So what we can say, alpha halo ketone, alpha halo ketone, when it is react with amide, it undergoes condensation reaction on heating, gives oxazole. So let's look into the mechanistic part. So Hex and hydrogen. Okay, where hydrogen, maybe let's take it from a simple way. H2 and O will go out as a water, and then afterwards, so there will be what is called, right, then X, and suppose I think you are aware about what is called ketoenol tautomerism. Okay, so you know that since this carbon is attached to halogen, this carbon is attached to ketonic group, this ketone and this carbon is what you call active carbon. The proton present on this carbon is active proton. So that means that can be easily removed. If it is removed means there will be anion formation. If it is anion forming means it will come over here and this will be available in the form of enol form. So that means here it is possible to remove one proton. That proton and X minus can go out as a HX. So here initially ketone can be converted into enol. Enol means double bond and OH. That enol can react with amide. And again you can remember that amide also it will be available in the form of enol, amide enol form. That means double bond here, OH here. The proton present on the nitrogen, it will move from nitrogen to oxygen. Then it's called double bond and OH. It's called amide enol. The elimination of simple molecules, it gives oxazole. So overall, the first method of preparation of oxazole is starting with the alpha halo ketone. This position is called alpha, and this is halo, and this is ketone. Alpha halo ketone, when it is react with amide, okay, it undergoes condensation on heating, gives oxazole. So this is a
Excuse me,
general
sir.
example. Yes, yes, you can ask if there
So
is
your
any doubt.
screen is freezed.
Freezed, huh?
Your
Uh,
screen is
uh,
freezed, sir.
no, no. Okay, I will come to the. I will come out from the what is called the presentation mode, so that I'm not moved. Only the one screen means. Okay, I will come out from the presentation mode so that it will. Oh, hello, hello,
Yes, sir. Yes, sir.
hello. Am I audible? Okay, okay. Is the screen
Yes,
is
sir.
visible now? Okay, right. Fine. So now I'm not putting in a presentation mode. So like this only you can, if you have any doubt in between, you can ask. So this position is called alpha position, and this is alpha halo, and this is a ketone. So alpha halo ketone, when it is treated with amide, it undergoes condensation reaction on heating, giving rise to oxazole. This is a general method. So in this, halogen can be chlorine, bromine, or iodine, or fluorine, and R1 may be a alkyl group or aryl group. Similarly, with respect to the amide, R2 may be a alkyl group or aryl group. So it's a general example. Then let me take example. Okay, what is the example I'm taking here? You can observe that this is a amino group, this is a methyl group, and this is called carboxylate, ethyl carboxylate. Then what is the name of this compound? Ethyl alanate. Alanate means you know that without this ethyl group, in place of ethyl group, if it is a hydrogen, then it is called alanine. Alanine is a amino acid. If the alanine is esterified, then ethyl alanate is a product. If this ethyl alanate, when it is treated with formyl, this group is called formyl, and this is acetate. Formyl acetate. So formyl acetate will act as a source of CHO. CHO means formyl group. Now, how the reaction? So how there will be a reaction, more particularly between this nitrogen and this carbon. So that means H2 and O will go out as a water molecule. So in a reaction between uh, okay anyway, what, so this complete part CH3NH2COO part is this, okay, and NH and CHO, this uh, NH is this. Is this. COO is this. Okay, and uh, uh, this CH is formyl group. And what is leaving group? Formic acid. So this particular reaction, and
Sir,
what
your
is the
voice
role
is breaking, sir.
of phosphorus pentoxide? Okay, how the ethyl
Sir,
alanate
your
and
voice is breaking.
formyl acetate is converted okay. Am I audible now? Hello.
Yes,
Okay,
sir.
right.
Yes,
Yes,
sir.
there was a disturb in the network. So now again I'm sharing, and this is a second slide. So more particularly, I'm talking about the how ethyl halanate is converting into a oxazole. So this is the structure of ethyl halonate. So this bond pair, okay, lone pair can form a bond with this carbon. Otherwise, bond pair itself can form a bond. Suppose lone pair is forming means the bond pair will convert as a lone pair. So when there is a new bond formation between this nitrogen Okay, let me present again. Okay, here there will be a new bond formation between this nitrogen and this carbon. Acetoxy group is going out. Then what N-formyl is obtained. The obtained N-formyl, it will be in equilibrium with the enol form. So how this bond pair will come over here, this oxygen picks up this proton. So that is the reason N double bond OH is formed. Similarly, this bond pair is coming over here, and this oxygen picks up this proton is obtained. So this movement cyclism agent. Otherwise, we can also say that a dehydrating agent. So remove of OH and H. So this O, it's a bonded pair of electron, whereas this H is going as a proton. So that means the bonded pair, the bond between the oxygen and hydrogen, it will form a new bond with this carbon-carbon double bond. So that is how a oxazole is obtained. So is there any doubt in this mechanism? Hello? Is there any doubt in this mechanism?
Sir, can you explain once again, sir? Because it's very breaking. Your voice is breaking, sir.
It's because of network issue. I think now it is stable. Uh, okay, I will explain again. So here I am talking about the how the ethyl halanate is converting into a oxazole. So ethyl halanate is a substrate or a reactant. So when the ethyl halanate is reacting with the formyl acetate, so that means there will be a new bond formation between this nitrogen and this carbon. So when there is a new bond formation between this nitrogen and this carbon, this group is called acetoxy. It will go out along with this proton. So acetic acid will be the leaving group. Then what is the product? There will be a new bond formation between this nitrogen and this formyl group. So that is the reason it's called N-formyl. Okay, this is called N-formyl. Then afterwards, So there will be a equilibrium. So these two are the canonical form or yes, resonance form. So what will happen? This bond pair is coming over here. This oxygen picks up this proton. Similarly, this bond pair is coming over here. This oxygen picks up this proton. So that is how a double bond OH, double bond OH. So we can also call it as a ene all, imine all. Okay. So it's an intermediate. This intermediate, when it is treated with phosphorus pentoxide is a dehydrating agent. It removes water. Uh, More particularly, OH and H is going out. There will be a new bond formation between this oxygen and this carbon. So that is how a what is called as oxazole is obtained. Okay, now tell me, is there any doubt? More particularly ethyl alanate to the oxazole. Is there any doubt?
No, sir.
Okay, now I will move to the next slide. So next slide, I am taking a method 2. So method 2 of synthesis or the preparation of oxazole. So this method 2 here oxazole. Okay, oxazole is synthesized by reductive acylation. So what is reductive acylation? I think you are aware about the reduction. Okay, so reduction of electrons. So what is happening here? This double bond is there, no? This double bond is converted into a single bond, and this OH is going out and forms a NH. So that is called reduction. Then acylation. Acylation means, so the obtained amine, when it is treated with acetyl chloride, it gives acyl product. So the conversion of what is the name of this compound? So C double bond NOH is called oxime. So when you are taking this as a substituent, oxamino, okay, ketone. This is the ketone. Again, oxamino ketone is a general name. Okay, and of course, this moiety also a general molecule. It's not a what is called as a specific one. It can be a specific. Suppose a R and R dash is equal to methyl or ethyl or propyl or alkyl or aryl group. So then, name of this moiety is called oxamino. This group is called oxamino, and this is ketone. CO is called ketone. Oxamino when it is treated with zinc in acetic acid. Zinc is a metal. It gives electron. So those electron was used by double bond, and double bond is converted into single bond. Acetic acid, it will act as a source of proton. So here once the zinc gives electron, double bond is reduced to single bond, and acetic acid will give a proton. So using that proton, OH is going out, and there will be a formation of NH2. C single bond NH2 is the product formed when oxamino ketone is treated with zinc in acetic acid. So when it is treated with acetic anhydride, the obtained amine is converted into acetyl group. So in this, two steps are involved. The two-step one, combinedly it's called as reductive acylation. So reductive means reduction. What is reduction? A double bond is reduced to single bond, and OH is removed and H is added. That means amine is obtained in the reductive step. In the acylation step, amine is converted into N-acetyl. Okay, so this is N-acetyl. So this is how this product is obtained. And again, now you know that again we are talking about the amide enol. So that means the lone pair or the bond pair can come over here, and this can picks up this proton. So this is amide enol tautomerism. The obtained one, it is treated with thionyl chloride. Of course, thionyl chloride is a what is called as chlorinating agent, but here it will act as a of course it's a chlorinating agent as well as a dehydrating agent. So why? Because thionyl chloride react with hydroxy group converted into chlorine, and the lone pair present on this oxygen. Otherwise, okay, what will happen? This OH can be converted with this carbon, and this will go out. So here removal of water is happening, removal of sulfur dioxide is happening, removal of HCl is happening, and what is the product? The product is oxazole. So this is about the second method of preparation of oxazole. So what is the second method of preparation of oxazole? Oxazole is synthesized by reductive acylation of alpha oxamino derivative. So this position is alpha oxamino derivative of ketone followed by dehydrative cyclization. Dehydrative means removal of water. So by removing water, it undergoes cyclization. So these are the one can found in synthetic methods. Okay, right. So this is the second method. So in simple way, it's not a simple way. You need to use the specific terminology called reductive acylation for this step. And this here to here is a hamide-hene tautomerism. From here to here, it's a dehydrative cyclization. Dehydrative means removal of water and then cyclization. So overall, what two steps are involved? One is reductive acylation, another other one iterative cyclization. These two words you need to remember when you are writing a method 2 synthesis of the oxazole. So oxazole is synthesized by reductive acylation of alpha oxamino. This is ketone, and this position is called alpha, and this group is called oxamino. Alpha oxamino ketone, when it is subjected to reductive acylation, it gives N-acetyl ketone, alpha N-acetyl ketones. This and gives rise to oxazole. So this is the second method of preparation or synthesis or manufacture of oxazole. Is there any doubt in this second method of preparation or synthesis? So if there is no doubt means I will go for a next slide.
For a minute, sir.
Hello? Any doubt? Any doubt? Is there any doubt?
No, sir.
Okay, right. So now I will take up electrophilic substitution reactions. I think you are familiar with the electrophilic substitution reaction. Under that chemical reaction, electrophilic substitution reaction. So you know that electrophile, NBS is a reagent. So it will act as a source of Br. The structure of NBS is this: CH2CO NH NBr. So this is only N-bromosuccinimide. This moiety means 4 carbon containing 2 carboxylic acid. One is called succinic acid. Succinic acid, it undergoes dehydration, gives succinic anhydride. The succinic anhydride, when it is treated with ammonia, it gives succinimide. The succinimide undergoes bromination, gives N-bromosuccinimide. It's a white yellow colored product, and it is sensitive to moisture. It can capture a moisture. Okay, so usually one can take what is the name of this compound? 2-phenyl oxazole. So 2-phenyl oxazole in a chloroform or carbon tetrachloride. To that, NBS is added slowly. As soon as the addition of NBS is complete, this reaction is formed. So this product is formed. Then what is the name of this product? 1, 2, 3, 4, 5. So fifth position bromine is there, 2 position phenyl is there, 5 bromo 2 phenyl oxazole is the product. Then how in terms of words, how we can say that 5 bromo 2 phenyl oxazole is obtained by the reaction of 2 phenyl oxazole and NBS. Okay, so that's all. So otherwise, in what we can say that 2 phenyl so bromination with undergoes bromination with the NBS. NBS means N-bromosuccinamide. It gives 5-bromo 2-phenyl oxazole. Then only one reaction I am showing for the electrophilic substitution reaction, and I am not showing nitration. Maybe in the next slide I will show. But again, one more thing, a nucleophilic substitution reaction. So nucleophilic substitution means a nucleophile is attacking to the second position. If the second position of the oxazole contains a leaving group such as chlorine, bromine, iodine, tosylate group. What is tosylate group? CH3, SO3, SO2 group containing one is called tosylate group. Tosylate also will act as a leaving group. Okay. So once the nucleophile approaches, here the nucleophile is N-methyl aniline. So the lone pair or the bond pair, when it is reacting with this carbon, chlorine will go out. There will be a new bond formation between this carbon and this nitrogen. That is how nucleophilic substitution occurs at the oxazole, more particularly at the second position. And then tell me, what is the position of electrophilic attack on the oxazole? Fifth position. Why? Because you are getting a 5-bromo. Br is the electrophile. So that means fifth position of the oxazole is the electrophilic attacking place, whereas the nucleophilic attack means second position of the oxazole. Is there any doubt? So with this, I will go to the next slide. So next slide, I am taking the reduction. So you know that reduction. What is reduction? Addition of electron, addition of hydrogen, removal of oxygen is called reduction. Suppose oxazole is subjected to reduction. You know that this is one double bond, this is another double bond. Both the double bond present in a oxazole is reduced. Means, and here what is the reducing agent? Sodium is the reducing agent. So what it will do? It will supply a electron. One sodium can supply one electron, means in terms of molecule I am talking. So 2 sodium is required to transfer a 2 electron on this carbon. If one electron is coming over here, this bond pair will sit on this nitrogen, and that bond pair can pick up a proton. And this is one electron is there. Again, sodium, if it is giving one more electron, then the 2 electron can form a bond with the proton, and the ethanol will act as a source of proton. So in this reaction, will act as a source of electron. Ethanol will act as a source of proton. So sodium gives electron, and once the 2 electron is obtained on a particular position, that will capture a proton from the ethanol, and a double bond is converted into single bond. Of course, this double bond is also converted into single bond. So this is called what is called reduction. Of course, if you want to write the mechanism, you can write the mechanism. The mechanism is sodium, after giving it will give one electron to this position, and this double bond, this bond pair means bonded 2 electron will sit on this nitrogen. Then this 2 electron can pick up a proton from the ethanol and convert it into NH. Now 1 electron is here. Again, sodium is giving one more electron, and sodium after giving Na plus. Once the 2 electron is obtained, that 2 electron picks up a proton from ethanol, giving rise to CH bond formation. So similarly, sodium, one more sodium can give one more electron here, and this bond pair can sit on this, and that bond pair can pick up a proton from ethanol, and a single electron, again it takes electron from the sodium. Once the 2 electron is obtained, that 2 capture a proton from ethanol, so giving rise to oxazolidine. So this is again, oxazolidine is a what is called as saturated. Okay, saturated means there is no unsaturated. This is unsaturated. This is a saturated one. Oxazole. Oxazole is for unsaturated one. Oxazolidine is for the saturated one as per the IUPAC nomenclature. So this is about what is called as reduction. Suppose a reaction, suppose oxazole is react with acid. Suppose oxazole is react with acid. So what are the acid source? HCl is the acid source, sulfuric acid is the acid source. So these are the commonly used mineral acids. Mineral acid, give one example for mineral acid means hydrochloric acid or sulfuric acid. So what is happening here? There will be a cleavage. How the cleavage? So this particular carbon is converted into carboxylic acid, and this oxygen is converted into ketone. This nitrogen is converted into amino. Okay, so there will be a breakage. This might what it means. It means that oxazole undergoes ring opening reactions with acid at high temperature, so giving rise to beta amino ketones and carboxylic acid. So that means on treating with mineral acids, more particularly on treating with mineral acids, for example, sulfuric acid or HCl, undergoes ring opening, okay, and gives rise to carboxylic acid and beta amino ketones. Why beta? Is it a beta or alpha? So this is a functional group. This position is called alpha. So that means alpha amino ketones. So is there any doubt in reduction as well as the treatment with acid? Hello? Is there any doubt in reduction as well as treatment with acid?
Sir, I have a doubt with reaction with acid, sir.
Okay, tell me.
Sir, how
So
that? Hello?
here there will be a, I think you know that what is called as ring opening reaction. So ring opening reaction means the oxygen present here, no? This lone pair also present on this oxygen. This lone pair can picks up a proton. Once there is a new bond formation between the oxygen, this bond becomes weak. Once there is this bond becomes weak, so you know that HCl is a gas. More particularly, HCl is a gas is saturated with water. So the water present in a HCl, it will attack here. So once there is a new, that means this bond break, O is converted into OH, and then water is attacking here. So once there is a bond formation between this carbon and OH, then what will happen? The bond between the oxygen and OH come over here, and this will pick up a proton. Again, this reaction is happening in presence of acid. Again, this lone pair can react with proton, and there will be a breakage of this bond, so that this carbon is added oxygen and then OH. This carbon is carboxylic acid. This nitrogen is converted into NH2. Then afterwards, this OH here, this ether group is converted into OH. So later on, what will happen? This bond pair can come over here. This hydride can go to this position. So that is how a alpha amino ketone is obtained. You want me to write a mechanism?
Yes, sir.
Yes, sir.
No, sir.
Otherwise, we can't understand, sir.
Okay, 1 minute. I will take a. I will. I have to. If I want to write a mechanism for this, I have to go for a presentation mode. I'm going. Okay, now I have to take a pen. Okay, so I'm taking pen. So look here. Now I'm writing. It will give you an intermediate. Okay, here space is there. Here I will write. So it will give you an intermediate like this. R group. Okay. OH. Okay. And then nitrogen is there now. So nitrogen, and then double bond, and then OH.
Sir, I can't see where you're writing, sir.
Red color one?
Sir, your screen is freezed, sir.
That's what. So if I'm going for presentation mode, it's you are not able to see the screen. Okay. So on regular one, if I'm not going for presentation mode, then I cannot write it on a screen. Okay. Maybe.
Sir, in teachment, you can write and explain at the same time, sir.
1 minute.
Teachment app.
I will. 1 minute. 1 minute. Is it okay? Look here. Is it possible to visible this one?
Yes, sir.
So that means
Yes, sir.
here what you will get a Har group. So this is the Har. So initially there will be a formation of intermediate like this. So then afterwards what will happen? This bond pair is coming over here. This picks up a proton. Similarly, there will be this N double bond C is there. No, there will be a breakage of this, converted into this is NH, and O is added to here. Is it clear now? So this is one key intermediate. Hello? Hello? Hello?
Yes, sir.
Is it clear now?
Yes, sir.
This is one key intermediate. So that means here Har group will be there. There will be a cleavage, this hydrolysis. N is converted into NH2, and C double bond takes the oxygen. So this part is carboxylic acid, and this part is a alpha amino acid. So this is one key intermediate. Is it okay? Is it okay, or shall I write it again? Hello? 1 minute. I will. So I will again. I need to. If I want to complete this one, I will take. No. Oh, okay. 1 minute. I will take it into a presentation mode. and take a pen. Okay, so here what is there? R group is there, and so from here, so what will happen? There will be a double bond, a single bond, R group. Okay, and then NH. Okay, NH2 more particularly, and then here ketone plus a carboxylic acid, C double bond O, and then OH, OH, and here R group. Okay, this is how is obtained in presence of H plus. Okay, and now I will come back to the normal one. Okay, look here. Hello. Now you look here. So initially this in presence of H plus. Hello. Am I audible? Anirudh?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Look here, what is happening? The lone pair present on this oxygen picks up this proton. So that is how OH is formed. Similarly, the water present in HCl attack here. So that is how this OH is formed. Once there is a intermediate formation like this, so in presence of H plus, because all this reaction is happening in presence of H plus only. The lone pair present on this oxygen picks up this proton. Once the lone pair present on this nitrogen picks up this proton, this bond pair will move over here. When this bond pair is moving over here, another OH will attack this carbon. So then again lone pair present on this oxygen picks up one more proton, and there will be a cleavage this one. So that is how carboxylic acid, that is how alpha amino ketone is obtained. Is it clear? Is there any doubt now?
No, sir.
Okay. So I will go to the next slide. I will go to the next slide. Okay. So next slide is about pericyclic reaction. I think you are aware about pericyclic. Here what is happening? Diene and dienophile reaction. So this will act as a diene. So I think you can observe that here three bonds is there. 3 bonds. Okay. This particular carbon, 3 bonds. 3 bonds is called benzene, Z-Y-N-E. Usually benzene means only 2 bonds. Okay, two bonds means 6 pi bonds, 6 pi electron. Whereas this benzene contains 8 pi electron containing one is called benzene. So I think benzene mechanism you are aware about it, isn't it? So what is happening here? There will be a new bond formation between this carbon and this carbon, and this carbon and this carbon, and already present double bond is converted into single bond, and there will be a new pi bond formation here between the carbon and nitrogen. So that's what I have written here. I will explain again. So 4 electrons. So 2 electron, 2 electron, 4 electron, and this is 2 electron reaction. It is also called as 4 plus 2 cyclo addition. So more particularly, this method is very useful for the preparation of bicyclic compound. Of course, this is a tricyclic one, but the reaction is involved between this carbon, this carbon, this carbon, and this carbon, and there will be a new pi bond formation here. So I will explain it again. So what is happening here? There will be a new single bond formation between the carbon. There will be a new single bond formation between this carbon and this carbon. Already existing double bonds disappear and there will be a formation of new pi bond between this carbon and this nitrogen. So this here again here a triple bond is disappearing, converting into a double bond. So these are the changes with respect to the reactant as well as the product. Is it clear? Is there any doubt? Of course, this is regarding pericyclic reactions in your fourth semester, not the fourth semester. In your third semester, you will about this pericyclic reactions. So at this moment, you just remember that 4 plus 2 cycloaddition means 4 pi electron and 2 pi electron are involved, and that leads to a bicyclic compound. That's what you can just remember. And one more thing also you can remember. So whatever the pi bonds disappears and there will be a new 2 single bond and 1 pi bond. Okay, 1 pi bond, 2 single bonds are forming. That's what that is also you can remember. Okay, tell me. I think this is a. Are you come across earlier this pericyclic reactions in your BSc studies?
Yes, sir.
Okay.
Diels-Alder reaction.
The Diels-Alder is nothing. Diels-Alder reaction is an example of 4 plus 2 cycloaddition.
4 plus 2 cycloaddition reaction.
Diels is a scientist. You know that Alder is a student of Deal. Okay, Alder got a Nobel Prize. Is it clear? Deals is a supervisor or PhD supervisor of Alder. Alder got a Nobel Prize for this invention of 4 plus 2 cycloaddition. This 4 plus 2 cycloaddition gives a novel bicyclic compound preparation. So this 4 plus 2 addition Diels-Alder reaction is very much useful in the preparation of more particularly 6-membered ring compounds in natural product chemistry. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So, right. Okay. So here, right. So there will be a new bond formation between this carbon and this carbon. That means these pi bonds are used in the new bond formation. These pi bonds are moving to form a new double bond. These pi bonds are used in a single bond formation. That is how this product is obtained. Is it clear? Is it clear? Is there any doubt?
No, sir.
No,
Okay.
sir.
Similarly, in this one, so this is 1 2 electron, this is another 2 electron, and this is another 2 electron. 4 electrons here, 2 electrons here. So 4 plus 2 cycloaddition. How this pi bond is involved in a bond formation here, and this pi bond will move over here, and this pi bond form a new bond with this carbon. So that is how an intermediate is obtained. Again, the obtained intermediate. So obtained intermediate is undergoes rearrangement. Okay, this is called electrocyclic reactions. So from here to from these two reactant to this product is cycloaddition. 4 plus 2 cycloaddition. From here to here, it's an electrocyclic reaction. So what will happen? This bond pair, okay, N carbon, this bond pair is coming over here, and this bond pair will come over here. This bond pair will come to here. So that means this C triple bond N will go out as a leaving group. So this part is there, no? This part is going out as a leaving group. And how many electrons are involved? 2 electron, 2 electron, 2 electron. 6 electron involvement in a cyclic manner is a concerted reaction, and this is the product is obtained. So what is the name of this product? Furan. And 1, 2, 3, 4. 3, 4. Furan, maybe you can say that ethyl group, diethyl, 2, 4, furan, di 8, ATE. Okay, is it clear? Is there a cyclo addition reaction? Hello? Is there any doubt in cyclo addition reactions of oxazole?
No, sir.
No, sir.
Right. So with this, I will go to the next slide. So next I am taking isoxazole. So isoxazole means and nitrogen are at 1 and 2 position. If the oxygen and nitrogen are at 1 and 2 position in a 5-membered ring is called isoxazole. So then how one can synthesize isoxazole? So isoxazole can be synthesized starting with a carbonyl compound. So what is the name of this carbonyl compound? This is 1, this is 2, this is 3. 1,3-dicarbonyl compounds. 1,3-dicarbonyl compounds, when it is treated with hydroxylamine, it undergoes reaction, removal of water, giving rise to isoxazole. So for your understanding, just I am explaining that. So look here, this is one oxygen, this is another oxygen, this is a hydrogen. So 2 oxygen and 1, maybe you can count that 2 hydrogen, 1 H and another H, 4 hydrogen, 2H2. And 2 oxygen, this is 1 oxygen, this is another oxygen, will go out as a water molecule. Once there is a removal of this proton, this bond pair will come over here, and this will form a bond with this nitrogen. So what is happening? You can, this bond pair is coming over here, and this bond pair can react with this nitrogen. Otherwise, the lone pair present on the nitrogen can attack here, and OH is going out. Similarly, the lone pair present on nitrogen can attack here, and OH will go out. So that is how a oxazole is obtained. And here is the mechanism, how the 1,3-dicarbonyl compound is converted into isoxazole. So the lone pair present, it will attack this carbon. Oxygen will go out, okay, with the this 2 hydrogen, removal of water. So giving rise to oxaminoketone. I think previously we discussed, no, this oxamino, okay, oxaminoketone. So but again, but this is not alpha oxamino. So this is a ketone, this is alpha, this is beta. Beta oxaminoketone is this. Then what will happen? The lone pair present on this nitrogen, of course, before lone pair present on this oxygen will form a bond with this carbon. Then this double bond is converted into OH. Then what will happen? This bond pair is coming over here. This OH is going out along with this proton. So bond pair is forming a new bond, and proton is going along with OH as a water, and this will be the product. What is the name of this product? Oxazole is the name of the product. So this is about the preparation or synthesis or manufacture of isoxazole. How the isoxazole is prepared? Isoxazole is prepared by the reaction of 1,3-dicarbonyl compounds with hydroxylamine hydrochloride. On heating, undergoes condensation reaction, giving rise to isoxazole. And R dash and R2 may be a alkyl group or may be a aryl group. So this is a general example, and this will be the general mechanism. Is there any doubt in the reaction and mechanism of isoxazole? Is there any doubt? Hello? Am I audible?
Sir,
Yes, sir.
explain mechanism once again, sir.
Okay, right. So look here. Hydrogen. I think you are aware about removal of hydrogen, H2 and O, removal of water. So before O, what is happening? The lone pair or the bond pair. Bond pair means between the nitrogen and hydrogen. So what it will do? They may involve in the bond formation with this carbon. Why it is reacting with this carbon? Because this carbon is electron deficient and this nitrogen is electron rich. So there will be a new bond formation between this nitrogen and this carbon. How? By the loss of hydrogen present at the same time by the loss of oxygen present on this carbon. This oxygen and this hydrogen will go out as a water. So maybe in between these two, I can write one intermediate. The intermediate means there will be a new bond formation between the nitrogen and this carbon, and this CO is converted into OH. That is the intermediate. So later on it says OH and H present on the nitrogen will go out as a water. So giving rise. So what is the difference between this C double bond O and here C double bond N? That is only the difference. That means oxygen is replaced by nitrogen and H2 and O will go out as a water. Is it clear? So this is the first step. In the second step, you know that this lone pair present on this oxygen will react with this carbon and C double bond O is converted into OH. And later on, this bond pair will convert as a double bond and this oxygen along with this bond pair going by taking this proton as a water. So that is how isoxazole is formed. Is it clear?
Yes, sir.
Okay. So with this, I will go to the next slide. So next slide, I am taking one more example. So what is the name of this compound? Without ethoxy, in place of ethoxy, if there is a oxygen, is called melanaldehyde. I think you are aware about called ketone and ketol, aldehyde and acetal. Acetal formation, ketol formation, I think you are aware, isn't it? So what is happening here? Without this ethoxy twice, if there is a oxygen, without this ethoxy, if there is a oxygen, it's called melanaldehyde. So melanaldehyde is treated with ethanol in presence of H plus to give melanaldehyde acetate. This CH is forming a bond with OET and forming a bond with OET. So OET means ethoxy group. Ethoxy group it will act as a living group when there is a reaction with the nucleophile. So what is happening here? So this nitrogen can form two bonds with this carbon. Similarly, this oxygen can form one bond with this carbon. And there will be a removal of proton from here and ethoxy from here, so giving rise to isoxazole. So here 4 molecule of ethanol is going out. 4 molecule of ethanol is going out. In addition to the removal, that's all. 4 molecule of ethanol is going out. So that is how a melanaldehyde acetate is converted into isoxazole on treating with hydroxyl. Okay, so this is the hydroxylamine. Is it clear? Is there any doubt? So here I am writing the mechanism. There will be a new bond formation between this nitrogen and this carbon. So ethoxy, 2-ethoxy group is going out by taking this H2. So that means CH double bond OH is formed. Then there will be a new bond formation between this oxygen and this carbon. 1-ethoxy by taking this proton going out as a ethanol. Then the proton, here CH bond is there, no? Removal of this proton and this ethoxy group, and this bond pair will convert as a double bond. So that is how a isoxazole is obtained. Similarly, name of this compound CH triple bond O is called propargyl aldehyde. Okay, this you can also call it as a acrylaldehyde. Okay, propargyl aldehyde or acrylaldehyde or propinaldehyde. Okay, IUPAC name is propinal. So this is asked in the question paper. Okay, of course this also is asked, but very recently predict the product and write the mechanism. That's what I asked for this. They given these two reactants. They asked you to write the product name. So what is happening here? There will be a new bond formation between this nitrogen and this carbon. H2 and O will go out as a water. Similarly, there will be a single bond formation between this oxygen and this carbon, and this one can pick up this proton. So that is how a isoxazole is obtained. Now tell me, is there any doubt in the preparation or synthesis or manufacture of isoxazole, starting with melanaldehyde acetal and propargyl aldehyde? Any doubt? Hello?
No, sir.
Okay. So just I will discuss the react in two slides, and afterwards I will stop. So with this, I will go to the next slide. So this is the mechanism. So propargyl aldehyde, how the react with what is called as hydroxylamine. N is forming a double bond with this carbon, oxygen and H2 is going out. So double bond is obtained. And oxygen will form a bond with this carbon, and this proton is picks up this bond pair. So that is how isoxazole is obtained. And the method 3, on treatment with beta ketoester. This intermediate you have seen in the previous method of preparation of synthesis. So what is the name of this compound? Ketoester. So this is called keto, and this group is called ester. Where is keto is there? This position is alpha, this position is beta. Beta ketoester. That means preparation or synthesis of isoxazole starting with beta ketoester on treating with hydroxylamine. So H2 and O will go out. So in place of nitrogen will come, and then this oxygen will form a new bond with this carbon, and this H, this O and this H will go out as a water. This H2 and O will go out as a water. So this is the product. Isoxazole is the product. So this is the third method of preparation of isoxazole. So I will go to the next slide. Next slide will give you the information about reactions of isoxazole. No, it's a mechanism. So mechanism of how the beta ketoester is converted into isoxazole. So the lone pair present on this nitrogen can react with this. H2 and O will going out. C double bond N is obtained. And this lone pair can react with this carbon, and C double bond O is converted into OH. Here one CH is there. Of course, here also CH is there. That I am writing here. This bond pair is coming over here. And this OH along with bonded pair and this proton will go out as a water molecule, and OET is retained here. So in the previous slide, I have not mentioned a ethoxy group at the 5th position, that you can write it. That is the correction for the third method of preparation of isoxazole. So with this, I will go to the next slide. Next slide will give you the reactions of isoxazole. So more particularly, electrophilic substitution reactions. Electrophilic substitution reactions in isoxazole occurs at the 4th position. So nitration, nitronium ion is the electrophile. So that will attack the 4th position. This is the 4th position. So ammonium nitrate in presence of trifluoroacetic anhydride. Trifluoroacetic anhydride, it will act as a solvent, whereas the ammonium nitrate will act as a source of NO2 plus electrophile. That NO2 plus electrophile attack at the 4th position of the isoxazole, giving rise to 4-nitro-isoxazole. Similarly, here methyl isoxazole undergoes nitration with a nitrating mixture, giving rise to 4-nitro-methyl isoxazole as the product. So with this, I will go to the next slide. The next slide is the sulfonation, and this will be the bromination. Sulfonation means sulfuric acid or sulfur trioxide is used as a source for the sulfonium ion electrophile. Isoxazole undergoes sulfonation with the sulfur trioxide, giving rise to oxazole 4-sulfonic acid. And bromination, it's a substituted bromination. So 4th position is, there is no group. So that means 4th position of the isoxazole undergoes electrophilic substitution with NBS. What is NBS? N-bromosuccinamide. This is the one. This will act as a source of Br+. So that means, what is the name of this compound? 1, 2, 3, 4, 5. 5-phenyl oxazole carboxamide. 5-phenyl oxazole carboxamide, when it's undergo bromination with NBS. ACOH means acetic acid, it's a solvent. MWO means microwave. Okay, microwave used for this reaction condition at 150 degrees centigrade, and 87% product is formed, the bromo at the 4th position. So we discussed about nitration, sulfonation, and bromination. Okay, for the isoxazole. Maybe we will also discuss about Diels-Alder reaction. So this is a Diels-Alder reaction.
Sir, explain once again nitration, sir.
Very good. Okay, nitration, no? This is the nitration. So nitration means nitrating mixture is used. Nitrating mixture means there is a possibility of forming nitronium ion. So nitronium ion attack the 4th position of the isoxazole. 4th position means 1, 2, 3, 4. This is the 4th position. So what is the starting material? Name of this compound? 5-methyl isoxazole. 5-methyl isoxazole, when it undergoes nitration with nitrating mixture, 4-nitro, 5-methyl, there should what you need to write 5-methyl 4-nitro-oxazole isoctane. Otherwise, what you can say that 5-methyl oxazole undergoes nitration with nitrating mixture gives 5-methyl 4-nitro-oxazole as the product. So here one more source of nitrating nitronium ion is the ammonium nitrate. Ammonium nitrate also acts as a source of nitronium ion NO2 plus. And here trifluoroacetic anhydride is a solvent. RT means room temperature. So 51% means the product formation of 51% product is formed. And here ammonium nitrate will act as a source of nitronium ion NO2 plus. That NO2 plus attacks the fourth position of the isoxazole. So giving rise to 4-nitro-isoxazole. This is about nitration. Of course, if you want to write the mechanism, you can write how the mechanism. First step is the sulfuric acid, it will be equilibrium with H plus and HSO4 minus. Second step, HNO3, it will be in equilibrium with OH minus NO2 plus. The NO2 plus attacks the fourth position of the isoxazole. The obtained cation is stabilized by resonance. And the fifth position is removal of proton and the product formation. So 5 steps are involved in electrophilic substitution reactions of nitration. Is it clear? Is there any doubt? Shall I go to the next one?
Yes, sir.
H2SO4 is one source. Another source is sulfur trioxide. Sulfur trioxide is a gas. So
ప్రతిసారి ఉన్నాడా క్లాస్లో?
లేదు.
ఏం ఎగ్జిట్ అయిపోయినాడా?
ఏమో చెప్పుకుండానే ఎగ్జిట్ అయిపోయినాడు.
ఇప్పుడేమో వస్తాడా లేడా వాపస్ అని?
వస్తాడు.
వెయిట్ చేద్దాం, 5 నిమిషాలు అంతే.
Is there any doubt up to this?
No, sir.
Okay. Maybe let me stop at this stage. Maybe maybe I will take one more class on Monday. Is it clear?
Sir, online or offline, sir?
Okay, sir.
It's offline, online, no, because many are. I think it's problematic with whoever is present in hostel, no.
Sir, when are you sharing PPT, sir?
PPT. You want PPT? Okay, maybe what I will do, I will convert this into a YouTube link and I will share it, the YouTube link itself. Is it okay? Or if you want notes, notes is already shared with one
No,
of
sir.
your
YouTube
friends.
link.
YouTube link I will
We
share
want
it.
both, sir.
Okay, fine, no problem.
Okay, sir.
I will share it
Okay,
immediately.
sir. Thank you.
I will share both the thing,
Okay,
YouTube
sir.
link as well as PPT also I will share. And the notes is, I think, is it the complete notes means complete means in the sense what I am taking the 2 units. So one is heterocyclic chemistry, another one is carbohydrate, and one more chapter is stereochemistry. Complete these 2 units notes is shared with your friend. You can collect it from them. Is it okay?
Okay, sir.
Okay, now I can. Now you can log out.
Thank you, sir.
It's all right.
Thank you, sir.
Thank you, sir.
It's all right.
Thank you, sir.
It's all right. Yes, is there any doubt? Okay, if there are no doubt means I will close meeting. Is there any doubt? Okay, I will close meeting.